Well, good morning, everybody. Here we have today, what is a scientific model? And does anyone have one? I've often thought about this because it seems the flat earth community thinks they have a model. You ask them if they have a model, and sometimes they say, oh, we don't need one. Sometimes they say, we have a model. So I thought I'd include a little joke. Why can't the computer take its hat off? Do you know that? Why can't the computer take its hat off? Answer at the end. So, what exactly is a scientific model? Here's some definitions I found. Scientific modeling is a scientific activity, the aim of which is to make a particular part or feature of the world easier to understand, define, quantify, visualize, or simulate by referencing it to existing and usually commonly accepted knowledge. That's from Wikipedia. Another one, scientific modeling, the generation of a physical, conceptual, or mathematical representation of real phenomenon that is difficult to observe directly. Scientific models are used to explain and predict the behavior of real objects or systems and are used in a variety of scientific disciplines ranging from physics and chemistry to ecology and even earth sciences. Although modeling is a central component of modern science, scientific models are at best approximations of the objects and systems that they represent. They are not exact replicas. Thus, scientists are constantly working to improve and refine models. That's from Encyclopedia Britannica. Why models are needed? Models allow us to investigate complex things that we don't understand well by using our knowledge of simpler things. Once a model finds supporting evidence and accepted, it can be confidently used to make reliable predictions about the phenomena it represents. That's from scienceornot.com. These are not scientific models. These are just models. Just like you have a model airplane or a model car, those are just models. They're not scientific models. So, what are the characteristics of a scientific model? Good models are hard to come by. They can't be built on the basis of whim or fantasy. Models must be grounded in solid scientific principles. A model explains a phenomenon by showing how it arises as a result of simpler or more fundamental phenomena. A good scientific model should include a mechanism. When scientists construct a model, they are hypothesizing that some poorly understood aspect of the real world can be compared, at least in some respects, to a mechanism that is well understood. Every scientific model must be refutable or falsifiable. We hear this a lot on YouTube lately. Everybody, flat earthers, globe earthers, everybody has this refutable or falsifiable, and they don't even know what it means. What it means is there must be a way of testing whether it's false. You can't just say it's that way because it's that way. A scientific model must be able to generate predictions. It will be accepted by the scientific community only if its predictions stand up against data from the real world. This includes predictions into the future. It also includes predictions into the past. So it's got to fit known historical data. Just like for eclipses, you can predict an eclipse into the future, when they will occur, but you also have to be able to fit, that model has to fit historic data for eclipses that we know took place in the past. And lastly, new models are more likely to succeed if they dovetail with existing scientific models. In fact, successful models often reveal that phenomena that were previously thought to be isolated are really connected. This was taken again from scienceornot.net. There's the URL there. Here are some examples of scientific models. The plate tectonic model of the Earth pictures the outer layer of our planet as broken into fragments called plates, which float on underlying plastic layers and slowly drift around. This model can explain the jigsaw fit of some continents, the origin of many earthquakes and volcanoes, and the global distribution of some living things, things that previously were not thought to be related. The second one, until recently, climate models had difficulty accounting for the effects of clouds. A new study reveals that the models need to allow for updrafts that rise to differing heights in the atmosphere, thus influencing whether clouds form. This refinement to climate models shows that the Earth is even more sensitive to carbon dioxide concentrations than was previously thought. The next one, there are lots of competing models for the extinction of the dinosaurs. We all know about the asteroid that collided in the Caribbean Sea off the coast of Mexico. Astrology attempts to account for human characteristics and predict events by using a model based on the positions of constellations and planets. This model offers no mechanism to explain the connection, and it cannot be scientific. I included this one because lots of flat earthers lately confuse astrology and astronomy. They're two different things. Astrology is certainly not scientific, and astronomy certainly is scientific. So here are some events in the globe Earth model that have to do with space. So in the 6th century BC, ancient Greek philosophers knew Earth was a sphere. 330 BC, Aristotle determined Earth a rotating sphere. In the 3rd century BC, Hellenistic astronomy, spherical Earth was a given. In 200 BC, thereabouts, Eratosthenes built upon that knowledge to calculate Earth's circumference and radius. And we hear about Eratosthenes a lot because he calculated the circumference. But you can see how it was built on previous knowledge. 5th century AD, Polaris was used for navigation north of the equator. So even as early as the 5th century AD, people knew that Polaris always stayed in the sky, and you could use it to find your latitude. 499, the Indian astronomer Aryabhata determined rotation. In the 10th century, Muslim astronomers accepted rotation. In 1020, Abu Sa'id al-Sijizi invented the astrolabe based on the motion of the Earth. So thousands of years ago, people were able to clearly see the night sky because there's no light pollution. One thing they noticed is that 5 sort of stars seem to wander faster through the night sky than other stars, and sometimes even going backwards instead of the same path. These stars were actually the planets Mercury, Venus, Mars, Jupiter, and Saturn. People called these objects wandering stars, which has been interpreted into English as planets. Somewhere I've heard flat earthers say planet is from some kind of evil prophecy person. Just doesn't make any sense. In 1608 to 1655, first of all, Hans Lippershey invented the refracting telescope. That's curious because I always thought it was Galileo. Galileo made improvements along with Kepler, Huygens, and others. In 1610, the 4 biggest moons of Jupiter were found independently by Galileo and also by Simon Marius. In 1668, Newton invented the reflector telescope. So here we go with some more. 1687, Isaac Newton published a comprehensive theory of gravity. He didn't discover gravity because of the apple falling on his head, but he got to thinking about gravity. He wondered what would happen if the cannonball went faster and faster and realized it would eventually fall around the curve of the earth forever and never hit the ground. This forever falling motion describes the movement of the moon around the earth and the earth and planets around the sun. Okay, let's skip to the 20th century. In 1946, the first photos of Earth from 100 miles up were taken using a 35mm movie camera, and it was taken by the Advanced Physics Laboratory. 1958 was the establishment of NASA. Notice that that's 12 years after the first photos of Earth from space. The new agency was to have a distinctly civilian orientation, encouraging peaceful applications in space science. 1969, we all know, was the first moon landing, and there were others after that. There's been continued study and missions across the world which will lead to a return to the moon and landings on Mars, which we're all excited about. Here are some predictions due to this model. Of course, day, month, and year. Our time is measured by the rotation and revolution of the Earth. Seasons are determined by revolution and tilt. Moon phases are determined by the sun and the revolution of the moon. Eclipses are determined by the revolution of the Earth and the moon. Planets, the positions and movements of planets and their moons. The Coriolis effect, caused by rotation. It in turn causes tornadoes, hurricanes, global wind patterns, like the jet stream, ocean currents, global weather events. Notice on your, if you watch your daily weather, the winds typically blow from west to east. That's due to the rotation of the Earth. Weather is difficult to predict due to so many variables. Even using today's supercomputers is still difficult. We might do a separate video about that sometime in the future. And the last one I have is space travel. So everything that has to do with space travel is built on this previous information that we have. The information that Isaac Newton, when he was talking about the cannonball, all of that has to do with satellites and the ISS. Those calculations based on gravitational pull has to do with the moon and traveling to the moon and our paths that we follow to get to the moon. So here you can see a lot of things that are predictions due to this model, this globe model. So now let's talk about the flat Earth model. And again, it's difficult to find any information about a flat Earth model because they don't want to talk about that. And they don't want to try to pin themselves down to a single model. In 1838, the Bedford Level experiment was performed. This had to do with a river or a stream by Bedford, and this was proven false in 1870 by Alfred Wallace, and it was more famously disproven by Jaron Campanella in 2018. In 1880s, Zetetic Astronomy is a book written by Samuel Rowbotham. It was pure conjecture from his interpretations of the Bible. In 1956, Samuel Shenton established the Flat Earth Research Society. When satellite images showed the Earth as a sphere, Shenton remarked, "It's easy to see how a photograph like that could fool the untrained eye." That was in 1956. In 1969, Ellis Hillman, upon Shenton's death, gave most of their library to the Science Fiction Society. I thought that was interesting. Flat Earth Society recruited members by speaking against the U.S. government and all its agencies, particularly NASA. Much of the Society's literature in its early days focused on interpreting the Bible to mean that the Earth is flat, although they did try to offer scientific explanations and some evidence. It kind of fell by the wayside for a while after Shenton's death. In 2004 was the revival of the Flat Earth Society, probably due to the internet and YouTube. 2013, part of the society broke away to form a new group with an internet forum and a wiki page. And I thought it was interesting that in 2014, Eric Dubé's first book on Flat Earth, and he was part of the Flat Earth Society at that time. And then also in 2014, Mark Sargent became active and wrote his Flat Earth Clues. All of that I think is connected. I guess you can think what you want to think. So there is the best I could find for Flat Earth model. Are there any predictions due to this model? No, there are none. No predictions. There's no information built on previous information. There just is no predictions due to the model. Okay, so my weekly joke. Why can't the computer take its hat off? Because the caps lock was on. Yuck, yuck, yuck. Stay tuned for more videos. I hope